Hello, everyone. How are you guys doing today? Good, bad, medium? Good. With them reading your exam, I'm going to give them tomorrow, not today. And we are going to fill out a reflection. That reflection is 2 points. So if you get all 100% in the exam, you still get 97 because you have that 3 points on the reflection paper. So tomorrow you're going to fill out the reflection. Once you get to your exam, fill out the reflection with the score you see in your exam. On your exam, you have 3 more points extra. How many is that extra? 3 more points will be added to your current score. Also, I already posted the review sheet for exam 2. Our exam 2 will be 2 weeks, within 2 weeks. Not this week, but next week, Thursday. So the date is 26. Mm-hmm.
What do you think we did?
There are few failing, probably 5 or 7. So it wasn't that bad, and also it wasn't that great either. It wasn't that great because I was expecting many points above 90, but I think I got only 2 or 3 above 90. And since it was multiple choice, as I expected, you thought you saw one answer in the multiple choice and you got the correct answer, which was wrong. So you didn't complete your work. Many of you didn't complete the work. For example, the second line problem, many of you saw one of the choice is the thing you have in your solution, so you stopped doing the work because you thought that is your answer, but it was wrong. So same thing like finding the equation of the line. You saw y-intercept is 1 and you have your slope is 1/2. So you thought, okay, it's 1/2 x plus 1, which is wrong. It's negative 1/2. It's going down. So common mistake, like you saw something on the choices, multiple choices, and you picked that without even realizing what you're doing. Okay. And also if you did solving the 2-line system of equations. So you solve them correctly, wonderfully. And then you are checking your x and y values, and you got the same answer on both left side and right side. And I said, oh, it's infinite solution. So you circled infinite solution for that. So get it wrong. Technically got it right because you have correct x and y value as solution. But at the end, you messed up your solution with the choices, and you pick the wrong one, so you get 0.
So let's say in the exam, if we get a C in all, do we still pass?
You still have 4 more exams in final, so don't worry about the first one. If you did not pass the first one, it's okay, as long as you pass the other 4 ones. Plus, even if you don't pass the other 4 ones, if you have at least next to 60, like around between 50 to 60 in all of your exam, but you have all your homework and quizzes done, you'll pass. So there are a few of you. You solved the first one. The solution for the first one was unique solution, like x equals 2, y equals -3, something like that. Okay. So answer was 2, -3. So you're supposed to circle both of them, 2 and -3. That's the answer. One of them is x, one of them is y. So what a few of you did was you got x equals 2, y equals -3, and then you substituted them into both equations. And obviously you got the left side equal right side because the answers are correct. So since you got left side equal right side, you thought since you have the same number on both sides, it means you have infinite solution. That's why you circled infinite solution instead of circling x equals 2, y equals -3. So the answer is wrong. See? So once you get your answer, you check, but when you check, you're supposed to have left side equal right side. It means the answer you have x equals 2, y equals -3, are correct. That's why you have the left side equals right side. It doesn't mean you have infinite solution. So I felt really relevant for those students who told me at the end the answer is infinite solution because the left side equals right side. High score is perfect score. Christopher had that. Only one, him. Besides him, there was no perfect score. Okay, so exam 2 will be on 26th, next week, Thursday. And I posted the review sheet based on our 4.5, which we're going to do today, and chapter 5, 10.2, and a little bit of chapter 6. So I'm not sure how much you're going to finish by tomorrow, not tomorrow, next week, Tuesday. So next week, Tuesday, we're going to decide up to what our exam will be. Okay, so for now, I made the review sheet up to 6.5, but probably we may not be able to finish or go up to 6.5. So whatever we finish by next Tuesday, our exam will be based on that. But since you already have the review sheet, just look at the review sheet. Okay, now you know how my exams are. They're very similar to the review sheet, and they're exactly same as what I tell you will be in the exam. Like remember last week I told you this will be in the exam, this will be in the exam. Did you notice all of the things I mentioned will be in the exam? They were in the exam. So basically I tell you before the exam what will be in the exam. Plus I'm going to tell you during lecture what will be in the exam. So study those very carefully. Okay, so 4.5. In the final exam, there will be one question from 4.5. Especially, they will be from either question 2, 3, or 4. So question 1 and 5, not so important because these are not bad. But 2, 3, and 4, definitely one of them will be from 2, 3, and 4 in the final exam. And definitely one of them will be in the in-class exam. Now let's see, what do we have? So what problems related to system of equations? When you face or when you do any type of what problem, your first step should be rewrite all these sentence into mathematical equation. And that is the hardest part, figuring out the mathematical equation for the scenario they give us. So what you should do is read word by word and interpret each word into some mathematical notation. So for example, the first one, two numbers, total 39. And one of them is twice the other number, find the two numbers. So two numbers, total 39. What does total mean? Do we add, subtract, multiply, divide in total? To get the total, what do we do? Do we add them? Do you subtract them? Do you multiply them? Or do you divide them? Add them. So two numbers, total 39. What does that mean? Two numbers, when you add them, you get 39. So let's say one of them is x and the other one is y. So that means if we add x and y, the sum is 39. So this is the first half sentence mean. Two numbers, total 39. Means x plus y 39. Now the next one says one number is. So let's say one number is x. What does is mean in mathematical notation? Equals. So x is twice the other number. Twice. What does twice mean? Do you add? Do you multiply? Divide what? Twice. Two times. So two times the other number, which is y. We divide when it says half. If this one number is half the other number, it means we are dividing. When it says one number is twice the other number, it means two times the other number. So one number is means x equal twice the other number means 2 times y. So we have two equations, system of equations. Now all we have to do is solve them. So which method do you have to do? Substitution or elimination? Substitution, because one variable is already alone. So we can replace this x here with 2y. So the first equation turns into 2y plus y equals 39. So how many y's we have? 3 of them. 3y is 39. And now to solve for y. We divide by 3. That tells us our y is 13. So we already found our y. Now to find x, we replace this y in here. So 2 times 13, that gives us x is 26. So the solution is x and y as a point format. So 26 and 13. So one of them is twice the other. Any question? Was any step unclear, confusing? No? Okay, the next one. Sulu buys 5 apples and 4 pears. And to buy those, he pays $22.80. If apple cost 3 times as much as pears, how much is the cost of the apples and pears? So let's see the first sentence. He buys 5 apples and 4 pears and pays $20.80.
5x plus 4y equals 20.
Let's say apple is A instead of X, so I can easily see what is what. Let's say apple is A and pear is P instead of X and Y. So 5 apple and 4 pears, the total cost is $22.80. So first sentence gives us the first equation. Now let's look at the second sentence. Apple costs 3 times as pears.
A equals 2.
Apple is 3 times pear. No. Apple costs 3 times as pears. So let's say if apple is $1, how much is pear? But doesn't it mean pear costs 3 times apple? Which one is higher, apple or pear? Apple. So if apple is $1, can P be $3? Should it be other way around?
Yes.
If pear costs $1, then apple is supposed to be $3. Oh, it makes sense. If pear is $1, apple is $3. My bad. Yeah, it's correct. So pear is $1, apple becomes $3. Sorry. My bad. Angel? Okay, so apple costs 3 times the pear. Makes sense. So we have 2 sentences, 2 equations. What do you do? First of all, we have apple, right? So we can replace our apple with 3p. So the first equation turns into 5 times 3p plus the 4p, $22.80. So we have 15p and 4p, which is total 19p is $22.80. And then to get the p alone, we divide by 19. And then you have two choices. Either you divide manually or you work with tenths. Let's do it manually and see what happens. So we have 2280 and we are divided by 19. 19 goes to 22 how many times? Once. 1 times 19 is 19. We subtract. How much is 22 minus 19? 20, 21, 22. 3, right? So we have 3. And we bring down the 8. But between 22 and 8, we have a decimal. So we must replace this decimal on the quotient. We don't bring it down next to the 3, but we have to put it up next to the 1. That's how we divide decimals. Now, 19 goes to 38 how many times? 2. So we have 38, and there is no remainder. So our P is 1.2. Or you can say 1.20 because money. Money has two places after the decimal. And technically we do have a place, it's this 0. We didn't use this 0, so just bring it up. So pear cost $1.20. Then how much is the apple? Good. Apple is 3p. So 3 times 120. So 3 times 20 is 0.60. And 3 times 1 is 3. So apple costs $3.60 and pear costs $1.20. Who is lost? Don't be shy if you're feeling lost, if you don't understand stuff. It's better to be asked in class instead of struggling during your exam and showing me you didn't understand anything. Should I explain what? Division, okay. Let's do it again. We had 2280 and we are dividing by 19. So when you divide, we look at 1 by 1. How many times we can divide? Can we divide 2 by 19? It's too small. So I take 22. Can you divide 22 by 19? How many times? Once. 1 times 19 is 19. 2 times 19 is 32. So 32 is too big. 19 is small. So we have only one 19 in 22. So 19 times 1 is 19 goes here. And then you subtract. So you have 22, you're subtracting 19, you're left with 3. And then you bring down the next number, 8, next to our difference. So 19 goes to 38 twice. So you put 2 and then 38 here. There is no more remainder. We have remainder 0. Now the answer will be 12 if it was 2280 without any decimal. Since it's decimal, so we have to use the decimal. So the decimal counts between 22 and 80. So for 22, we got 1. And from 8, we got 2. So our decimal has to be exactly on the same place between 22 and 80, which is between 1 and 2. So in 22, 19 goes 1. And when we use the 8, 19 goes 2. So between 1 and 2, we have to order stuff. Also, we did not use this 0. Since you didn't use this 0, you can simply bring it up. Whatever you don't use, any 0 you don't use, we can always bring it up in the answer in the quotient. So it's 1.2, but it's the same as 1.20. Then that 0 we have after the number of the decimal, those 0 doesn't count. So if you want, you can put many, many, many zeros. They all means the same thing, it's 1.2. But since you're dealing with money, for money, usually we have 2 places for coins. So that's why we put 2 zeros, 1 0. So you have 2 places after decimal. What's wrong with my? Is it clear, Angel? Okay, the next one. Think about the next one. Oh, let me take the attendance. Brandon, Liliana, Martin, Christopher here, Axel, Matthews here, Eliza, Angel here, Honda here, Maria, not Mariam, Maria, Ashley here, Exona, Jason here, Jason no phone, Kathy here, Asim here, Taylor, Chriselle, Alicius, Mariam here, Bennett, absent. Hey, Chanel, Yusuf. How come I have same thing twice? Justin, right? Jonathan. Wow. Is there anybody whose name I did not call? Ready? Who can give me the fast equation? What is the fast equation for this scenario? Or one of the equations? It's let's say you're going for a party or you're throwing a party, and then your budget is only $24 because you're broke, and then you need to buy 30 pieces of avocado and kiwi. The problem is each avocado is $1.50, where each kiwi is only 50 cents. So one of them is more expensive than the other one. So how many of each of them you can buy? Real life scenario. You have only $24 to buy 30 of them. Just kind of looking awkward, right? 30 pieces with $20. So $24. So how many each of them you can buy? What is one of the equation? Christopher. If you have 30 and 30 carry, you have total 60 pieces. So if you write 30 avocado and kiwi is $24, how it tells you the $24 is the money? A is 24, definitely not true, right? You want the total money has to be 24. But before you looking for the money, total amount of fruits, how many total amount of fruits you need? 30 of them. And what type of fruits you're going to buy? Only two, right? Avocado and kiwi. So what is our first equation? But your budget is only $24 and look at the price. Avocado is 3 times more than kiwi. Kiwi is only 50 cents. Avocado is $1.50. So it definitely cannot have same amount, 15 and 15, right? That will not going to add up to $24.
A plus A equals 24 over 30.
Why 24 over 30?
Because 30.
But A is number of avocado and K is number of kiwis. So number of avocados and number of kiwis, total how many you want?
30.
So A plus K is 30, not 24 over 30. 24 over 30 will be the money amount if you're working it. But the first one is quantity. How many total you want? 30 of them. Which type? Both avocado and kiwi. So avocado and kiwi, their combination has to be 30 pieces. So first equation is how many pieces you need. Number of pieces. The second one is the money. You know, definitely you can spend only $24. So the question is, how can you decide how much is the $24? Excuse me. So what equation you can have for the money? Let's make it simpler. Let's say you don't have $24, you have only $2. Only $2, okay? Suppose you have only $2. So how many avocado and how many kiwi you can buy?
150 A plus 150.
So you have 150 for your avocado and you have only 50 cents for your kiwi. So say 150 avocado plus 50 kiwi will give you $2. So one avocado plus one kiwi is $2. So 150 is each avocado. So here we know we have to buy only one of them and one of them. So one kiwi and one avocado is $2. But for $24, do you know how many avocado you can buy and how many kiwi you can buy? Do you know now? We don't. So instead of one, we use their number. We don't know how many avocado we have to buy. We do know each avocado is $1.50. So $1.50 times number of avocado plus 50 cents for number of kiwis, which we don't know how many we have to buy, the total amount has to be $24. So for this type of question, we have two types of equation. One is the quantity of your materials, how many you have to buy. So quantity of your pieces. And the second one is how much money you have. So one is for quantity and one is for money. For money, it's the price times the quantity plus price times the quantity will give you the total money. And for only quantity is number of things you're buying. Total has to be the number of quantity you have to have at the end. So like 30 fruits, it means avocado and kiwi is 30. So avocado plus kiwi is 30. The hardest part is figuring out the equations. But once you know equations, your life is easy. But we don't like something here, right, in these two equations. What do you don't like? Decimal. People don't like decimal and fraction. So there is a way we can get rid of the decimal. Do you know how can I get rid of the decimal, Martin? Multiplying by 2. Yeah, you can do it, multiply by 2. If you multiply by 2, then what is 150 times 2? $3. So 3A, and what is 2 times 0.5? 1. 1K, and what is 2 times 24? 48. So now this one doesn't have any problem. 3A plus 1K is 48. So here multiplying by 2 is easier because all you need to do is double each quantity and the decimal will get vanished. But let's say if you multiply by 2, it doesn't help. If it doesn't help, then you can multiply by 10 or 100. Anytime you multiply by 10 or 100, a decimal will get vanished. But when you multiply by 10 and when you multiply by 100, it based on how many numbers you have after the decimal. For example, if you have 1.5 and you don't want to get it to the 5, you can multiply by 10, it will turn into 15. If you have, let's say, 1.25, now after decimal, you have 2 places. So this time you have to multiply by 100, so it will turn into 125. So anytime, for example, if you multiply by 2 here, you don't get it at the decimal. Because 25 is 5, which is 0.5, and 1 is 2, so this becomes 2.5. We still have a decimal. So multiply by 2 doesn't help here, but if you multiply by 100, the 1.25 will turn into 125. So after 1 you have 20, that 20 cancel these 2 places decimal because there are 2 places here. So decimal for 2 places multiply by 100 will turn into a whole number, 125. But let's say you have 1.123. Can you guess now what did you multiply by to get a whole number? 1,000. How many places after the decimal is supposed to have that many zeros? So those places and those zeros, they cancel out. So you have 1, 1, 2, 3 without any decimal. Okay. But in our case, 2 is fine. So our first equation is A plus K is 30. The second equation becomes 3A plus K is 48. Which method do you want to use, substitution or elimination? Elimination. For elimination, all you have to do is multiply this by negative or the first one by negative. Let's say multiply the first one by negative. If you multiply this by negative or -1, all the sign will change, right? So let me rewrite. This will turn into -A, -K, -30. And we have 3A plus 1K is 48. And now if you add them, Plus k minus k, cancel out. No more kiwis, we have only avocados. So how many avocados we have here? 1a minus 3a. 2a, positive. And we have negative 30, positive 48. How much? 18. 9 is the answer, but when you subtract, the answer is 18. And then to get the avocado alone, so you divide by 2. So we can have 9 avocados. So how many kiwis then? Total is 30 of them, right? So if you subtract avocado from 30, you get your number of kiwis. How many? 21. So 9 avocados and 21 kiwis. Since avocados are expensive, so you can buy only 9 of them. And kiwis are less expensive, have more than 20. Any question from anyone? Who is lost? Anybody? Nobody? So these two are most famous question. You'll see at least one of them in the final exam. Definitely. And if you don't see one of these, that means you're going to see the next one. Something like next one. Renton. You're supposed to get the same answer. I use elimination because you see the k, so you can simply cancel the k with elimination. The next one is interesting one. You have a piggy bank, and you know, you have total 19 quarters and nickels. Unfortunately, you forgot how many each one of them. But you just remember you have 19 of them inside the bank. And somehow you know the total money you have in there is $3.55. Now you have to figure out how many quarters you have in there and how many nickels you have in there. Eliza. So quarter and nickel total is 19 of them. So we have quantity or pieces, P-I-E-C-S, P-I-E-C-S. So quantity or pieces for one equation, and the other one is obviously the money one. .25Q, 0.5N equals $3.55. 0.5. Good. 0.5 means you have 50 cents. We don't have 50 cents, right? How much is each nickel? 5 cents. So it's 0.5, not only 1.5. 0.5 means 5 cents, only 5 means 50 cents. And now look at this one. If you multiply by 2, it doesn't help you. So after the decimal, we have 2 places, non-zero number. That means if you multiply by 100, your life will be easier. It will turn into 25Q. And how many nickel? 5 nickels, 355. No more decimal. Even though the numbers are big, but at least you're happy because there's no decimal. So we have quarter plus nickel equals 19. And we have 25 quarter plus 5 nickels equals 355. What do you want to use? Elimination or substitution? Which one do you think is easier? You want to use substitution? It's up to you. What do you vote? Elimination? So if you want to use elimination, which one will be easier to get rid of? Q or N? N, because N has smaller number. So what number we want in front of N? -5. So you have to multiply this entire equation by -5. So -5q minus 5n, and let's see how much we have here. 19 times 5. How much? 25? 205. You sure?
No.
9 times 5 is 45, so you put 5 here. 5 times 1 is 5, plus we have that extra 4, so it's 95, not 205. So this thing here, let me write, it's -95. And then we add the two equations. +5 and -9 and -5 and cancel out. We have 25 quarter minus 5 quarter. How many quarters we have? 20 of them. And then we have 355 minus 95. 260. So we divide by 20. So now when you divide 260 by 20, you have 0 on the top, 0 on the bottom. Just cancel them. Anytime you have 0 after the number, you can always cancel all those zeros. You cannot cancel a 0 between two numbers, but you can cancel a 0 after a number. So what is half of 26? 13. So Q is 13. Then how many nickels we have? 19 minus 13, that gives us 6. So piggy bank has total 19 quarter and 5 nickels. Sorry, 6 nickels. So total you have 19, and then if you multiply 13 by 0.25 and 6 by 0.05, it's supposed to get $3.55. You can use substitution, you get the same answer. Any question, comments, anything? Was any part unclear to anyone? No? Then one more question, the last one. Dan Butler has been pricing speed pass train fares for a group trip to New York. 3 adults and 4 children must pay $94, and 2 adults and 3 children must pay $66. Find the price of the adult's ticket and the price of the each child's ticket. No phone. Three equations because we have two sets of information. So let's say adult is A, children is C. So 3A plus 4C, how much? 94. And then next piece, 2A, 3 children, how much money? 66. And here, using substitution, we'll give you fraction. So it's better to use elimination. But unfortunately, none of the coefficient is 1, and all of them are different from one another. So to multiply each equation by something. Eliza? Perfect. If you want to get rid of, let's say, adult, so we want to have the same number in front of A. The first equation has 3, the second equation has 2. So all you have to do is multiply 1 by other one. Multiply 3 by 2 and 2 by 3. You have the same number 6. But in order to eliminate, one of them has to be negative. So multiply one of them by negative number, one of them by positive number. So the first one turns into negative 6A minus 8C. What is 94 times 2? 4 times 2 is 8. 9 times 2 is 18. So negative 188. The second equation becomes 3 times 6A. 3 times 3 is 9C. And we have 66 times 3. 3 times 6 is 18. 8 goes on the bottom. 1 goes on the top as an addition. 3 times 6 is 18. Plus 1 is 19. So plus 198. When you add them, plus 6A minus 6A cancel out. How many C we have? Minus 8C plus 9C. 1C. And we have negative 188, positive 198. 198 is bigger, so it's basically 198 minus 188. 10. So children ticket costs $10. Now for adult, we have to use substitution. So 3A plus 4C equals 94. Our C is 10, so we have 3A plus 40 equals 94. Subtract 40. We have 3A equals 54. Then we divide by 3. And let's do it manually again. 3 goes to 5 how many times? 1. So 3 times 1 is 3. We write below 5, then we subtract. 5 minus 3 is 2. We bring down the next number next to the 2. So we get 24. Now 3 goes to 24 how many times? 8. 3 times 8 is 24. When you subtract, there is no remainder. So our A is 18. The adults ticket is $18 and children ticket is $10. And with this, we are done with system of equations. Your homework is due next week, Monday. And your homework has so many different types of questions. Whatever you don't understand, go to your PLTL. During your PLTL, ask them. Just don't tell them it's homework. They're not technically allowed to help you with the homework. But write down your question and ask them on the paper instead of using the computer. Okay? And if you do use AI, make sure you use more than one AI because AI doesn't give you correct answer. They are sucks at math. Okay? So if you use ChatGPT, don't use ChatGPT only, use other AI and then compare your answers. Okay, Mariam. So this is 4.5, we are done. So next week, Monday, we have homework and quiz 4.5. Not only. Today we just did 4.5. So we are going to do a lot this week. So each section we finish in class, we have homework due on Monday. So for now, it's 4.5. Brandon. Huh? I only updated till tonight, I think. All the homework due tonight. You can see their due date. So I have to update new dates after we finish new sections. So today we finished 4.5. So we definitely have homework 4.5 and quiz. And now we are going to do chapter 5. So you're going to have chapter 5 homework. Definitely 5.1, 10.2, and then the rest, I'm not sure yet. So any question before we move on from chapter 4? We are done in chapter 4. No more question from chapter 4. So from here, definitely one question. Not this one, but either this one or this one or this one. One question from these three, definitely you see in the final exam. No, I shouldn't say one question from these three. One question from this type of question from these three. Not the same question, but this type of question. So if you understand these three type of question, you'll be able to do any type of, this type of question.
You'll be giving us.
I already posted the review sheet on Blackboard. Sorry, Brightspace.
No, the final.
For the final, all the in-class review sheet are the review sheet for the final. I don't have any extra review sheets because I'm not making the final. Department is making. I'm just giving you the suggestion based on my previous experience. Okay, so we are going to chapter 5.
I was telling you that there's a final PDF on the stack website.
You can definitely practice with those. They are the same type of question, different number, different everything, but same type. And you only need to know how to solve a type of question.
And there's videos on the website for how to do every single.
Exactly. So you don't need any extra tutors. The videos are there. All you have to do is watch it if you don't understand something while you do it by yourself. Plus, you have your PLTL leaders.
So it's on South.
And tutoring.
So.
Downstairs. Second floor.
Mm-hmm. Can you share the website with them?
Which website?
The videos with the questions.
Oh, I showed mine. But SAC, Baruch, SAC, SACC. There's for this class, for pre-calculus, there's a final PDFs and how to count. And that's where you also book a appointment. Book an appointment.
Oh, so go to SACC and then go to that page.
So it says math 1022 sample final.
Yeah.
Okay, now we are starting chapter 5. Now, chapter 5 has good thing and bad thing. Bad thing is exponents. You have to know so many exponent rules. Especially for 5.1, it connects with 10.2. So once you're done with 5.1, you'll directly go to 10.2, and then you're going to do 5.3, 4, 5, those things, 5.23. So we are going to learn so many exponent rules. Let's start with something basic. First of all, exponent means repeat your base. So whatever we have on the downside is called base. Whatever we have on the power is called power, exponent, index, all these things. Now, power tells us how many times you have to multiply the base. So 6 cubed means 6 times 6 times 6. What does 4 to the 1 mean? Multiply 4 only once. So it's simply the number 4. How about 3 square mean? Multiply 3 twice. So it's 9. And now comes multiplication and exponent. So what comes first, exponent or multiplication? Good. So we keep our 3 times. And what is 2 to the 4? 16. It's 2 times 2 times 2 times 2. And now comes multiplication. 3 times 16 is 48. If you don't know, you can multiply 16 times 3. 3 times 6 is 18. 8 goes on the bottom, 1 goes on the top as an addition. Excuse me. 3 times 1 is 3, plus that addition 1 becomes 4. Or just memorize it, because you're going to use so many times 3 times 16 in this class. 3 times 16, 4 times 16. A lot you're going to use. That was easy, right? Exponent. Now let's see what happens when you have a negative on the base. So you all know 4 square. What is 4 square? 16. Now between B and C, what's the difference between B and C? Parentheses. B doesn't have a parenthesis, C does have a parenthesis. And parentheses makes a huge difference. When you don't have parentheses, it means multiplication. So this is same as negative times 4 square. So what comes first? The times or the power? Power, right? So negative, and what is 4 square? 16. So answer is negative 16. On the other hand, when you have a parenthesis around your negative, that means this entire thing inside the parenthesis is your base. So you have base with the power 2. So what you're multiplying twice? 4 or negative 4? Negative 4. So what is negative 4 times negative 4? Positive 16. See the difference between having a parenthesis and not having a parenthesis. Parenthesis means base. So you have to use the power on the base. But no parenthesis means multiplication. Just like this one, 3 times 2 to the 4. And here you have negative times 4 square. So negative 16. Will you also remember this in your exam? No. Unfortunately, you must, because I'm going to put these in the exam. One of these, I mean not one of these, both of them with different number, like probably negative 6 square and then parenthesis negative 6 square. Find them. Okay, now let's see. Volunteer for D. Who wants to try D? Mariam. 3 times 4 turns into 12. Perfect. Who wants to try E? So this is 3 times negative 4 because negative times 2 squared. So negative 12. Who would like to try F? John.
Well,
So this is 3 times positive 4. So it's 12. And it's positive 4 because your base is negative 2. So negative 2 times negative 2 turns into positive 4. Any questions so far? Okay. Now evaluating expression. So anytime you substitute your variable with any number, always use parentheses. Always use parentheses when substituting anything for any variable. Try to make it as a habit. Even though you don't have to, but still always use substitute use parentheses. For example, here 3 parentheses to the 4 because they told us our x is 2. So we are substituting x with 2. So rewrite your expression instead of the variable, just use parentheses and then substitute whatever they give you the information. It makes a huge difference. So what do we have? Handa?
48.
3 times 16, 48. So see, you're seeing 48 twice already. 3 times 6. Any question for me? Any comments, concern, complaint? Okay, try this. And once you're done, I have one more. Most likely next week, Tuesday, we're going to have online class. I'll let you know Monday. But most likely for now, I think it will be online. And I'll give you the link on Monday. Only next week, Tuesday. And next week, Thursday, you have your exam. So whatever you don't understand Tuesday, go about that on your dealing with PLTL on Wednesday. If you're done, try this. Team, are you done with both of them? Great. Ready? Matthew. B. What is -4 square? -4 square. 16, not 8. So it's 6/16. And then is it reducible, 6 and 16? They both are divisible by 2. So you divide by 2, you get 3/8. I bet half of you have -16 on the bottom. Right? Many of you have -16 on the bottom. That's because you did not put the parentheses around that. Am I correct? See, if you don't put a parenthesis around that, and if you think this should be 6/-4 square, it's a huge difference. You are saying here your base is only 4 and negative is a multiplication. So you get 6/-16, which is wrong. That's why I said here, anytime substitute any variable with anything, always use parentheses. Because of the parentheses, you see what's going on. Is it -4 square or is it -4 whole thing square? Okay? It is positive because you are replacing x with -4. So entire x is -4. So -4 entire thing, get the square. So it's -4 times -4, which is +16. But this one is negative times 4 squared, which is -16. Okay, let's see. Channel for the next one. -1 inside the parentheses. -2 with the cube. Now, what is -1 square? +1 and -2 cube. -2 cube means multiply -2 3 times. What is -2 times -2? +4. What is 4 times -2? -8. So this is -8, not 6. It's a common mistake. People like 6. -40. If you did not put parentheses, you would get +40. Because you might think -1 square means negative and then 1. So see, huge difference. Any question? No question? Okay, then comes rules. We are going to learn few rules, but instead of giving you the rules directly, we are going to derive the rules. So the first rule, a to the power m, whole thing to the power n. So let's see how do you derive that. Let's say 2 squared times 4. So 2 squared to the power 4 means you're multiplying 2 squared 4 times. 2 squared times 2 squared times 2 squared times 2 squared. But each 2 squared means 2 times 2, right? 2 squared means 2 times 2. So each of them will give you 2, 2, 2, 2, 2, 2. And you're multiplying all of them. So at the end, how many 2's we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them. Let's try one more example. Let's say have 5x 3 times. Sorry, my bad. Let's say we have x3 4 times. So x3 4 times, it means we have x cubed 4 times. And x cubed means we have x, 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 x. So what do you observe? How many x's we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them. So what exactly you did here, so that comes into 12. Multiply the exponent. 3 times 4 turns into 12. 2 times 4 turns into 8. So what's the general rule? If we have powers together, what do you do with them? Multiply them. So it's a to the, let me use red, a to the power m times n. Not only 2 powers, if we have 3 powers, 4 powers, 5 powers, it doesn't matter how many powers you have, all the exponents, you have to multiply them. So keep your base only once, multiply your powers. The second one, 2x to the power 4. It means we have 2x 4 times. So how many 2's you see? 4 of them. How many x you see? 1, 2, 3, 4, 4 of them. Let's do one more example. Let's say have 5y power cube. It means they're multiplying 5y times 5y times 5y. So how many 5's you see? 3 of them. How many y's you see? 3 of them. Now what exactly you did this power 4 so that it turns into this way? What did we do? Distribute. So everything you have on the base, we have the same thing, power many times. 5 we have 3 times, y we have 3 times. So that's how we have 5 cubed, y cubed. So what's the ruling here? If we have more thing on the base but only one power, what do? It distribute the power into everything on the base. So a to the n times b to the n. This is our rule number 2. Rule number 1, one base more power means keep the base, multiply the power. Rule number 2, more base but one power means distribute the power. The next one is same as multiplication, but this time we do addition. So 2/3 to the power 4, it means we have 2/3 times 2/3 times 2/3 times 2/3. So how many 2's you see on the numerator? 4 of them. And how many 3's you see on the denominator? 4 of them. So what did you do with the power? Same thing we did in the multiplication. Distribute. So it doesn't matter whether we have multiplication or division on the base, If you have only one power, you always distribute the power on the base. So you have a to the n over c to the n. So more than one thing on the base, either multiplication or division, it doesn't matter. If you have one power, distribute. Everything on the numerator and denominator gets the same power. Any questions so far? Now let's see next example. 2 cubed means 2 times 2 times 2. 2 to the 4 means 2 times 2 times 2 times 2. So how many 2's we have? 1, 2, 3, 4, 5, 6, 7. So what did we do here? Added. So in this case, we add the powers. So when you have same base, they're multiplying, you add the powers. But the rule is the base has to be same. If the bases are different, you cannot do that. As long as you have the same base, you keep the base, but you add all the powers. And I think the last one, yep. The last one is division. For division, we have two scenarios. Either the numerator is bigger or the denominator is bigger, something. So let's see what happens in each scenario. When the numerator is smaller, 2 cubed means 2 times 2 times 2. 2 to the 4 means 2 times 2 times 2 times 2. Each 2 from the numerator and denominator can be cancelable, so we cancel them. So what is left? On the top or on the bottom? On the bottom. What is left on the top? It canceled everything, so what is left? 1. In multiplication or division, if you have nothing, it means 1. In addition or subtraction, if you have nothing, it means you have 0. Now look at this scenario.
Can you explain the other way? Like if it's only becomes 0.
For example, if you have 2, this is same as you have 2 plus 0. So for addition subtraction, you have 0. But if you have multiplication, it's same as 2 times 1.
So 2 and minus 1 equals 1.
So 2, 2, 2, 2, and you have 2, 2, 2, 2. It cancels. This time, what is left? Oh, yeah, on the top or on the bottom? Top. So see, when the denominator is bigger, our answer is on the denominator. If the numerator is bigger, our answer is on the numerator. For division, we have two scenarios. If the denominator is bigger, the answer is a to the m minus n. So the answer will be on the numerator. But if the denominator is bigger, then the answer will be 1 over a to the n minus m. Brendan. Yeah, you can do that, but here I'm showing you the rules. What if you don't have number, you have variables, like 2, like x on the top and then something on the bottom. Like what do you do in division, general division case? But for numbers, definitely, you can multiply the numbers divided by your number. So division has two scenarios. If the numerator is bigger, your answer will be a whole number. The entire thing. And if the denominator is bigger, your answer will be a fraction. So here our denominator is bigger. Our answer is a fraction. Here our numerator is bigger, so our answer is a Any question, Eliza?
So like, say it goes 2 to the 5th power. Would it be 1/2 to the 5th power?
So tell me the question.
There's 2 to the 5th power over 2 to the 5th power.
So denominator, keep it denominator, the numerator. So what is 5 minus 3? 2. And what is 2 square? 4. What goes on the top? 1. When the denominator is bigger, the answer has to be the denominator. When the numerator is bigger, the other way around, let's see here, 2 to the 10 over 2 to the 7. Obviously, 10 is bigger. So keep you 2 to the 10. And you subtract the 7 from the denominator. So it's 2q. And what is 2q? 2 times 2 times 2? 8. So see, numerator bigger, answer is whole number. Denominator bigger, answer is a fraction. With this, you're done. Tomorrow, we are going to do examples of all these rules, and we're going to learn more rules. Okay? Tomorrow.
The 1/2, and that's the minus 1/4.
So this one, you can write same as 2 to the negative 3, 2 to the negative 2, but you cannot leave your negative exponent. So you have to write 1 over 2 square, which is 1 over 4. Negative power means a fraction. Hello. So have a good day, everyone.